Good afternoon, sir. I am Pooja. My partner Shraddha. We are done a project called Solar Tracking Panel. This is our project poster. This is my project. Before I demonstrate my project, I would like to give few information about my project. That is, what are the tools we have used and how it gonna work. And before telling about that, also I would like to tell what is the difference between the existing solar panel and other project which we have done. When it comes to the existing solar panel, it will just observe the sunlight from of morning 11 o'clock to 2 o'clock. When it comes to before that, it won't observe the sunlight. It is just a waste of the energy which we are getting naturally. So when it to use that natural energy completely, we are done with a project called solar tracking panel. When it comes to in this project, when the sunlight falls on that LDR sensor, it will start observing the sunlight, where we can use our solar energy completely without wasting even a single thing. Also, before I demonstrate about our project, I would like to explain what are the tools we have used. This is the LDR sensor, the 4 LDR sensor we have used, and this is the Arduino board. This is the voltage divider, it is the H bridge, and one Wi-Fi module, and this is the power supply. Before I'll going to the demonstrate, let me explain how it works. When the light sensor sends the light, this panel will start rotating towards that light. And from this light, it will give an input to the Arduino. From Arduino, it will go to the voltage, where this voltage divider, it will take the 7 voltage as the input and give the 5 voltage as the output, and this 5 voltage will be the input for the H bridge, and this will start controlling the motors. In this project, we have used 2 DC motor, as our project is a dual axis solar panel. Let me demonstrate this. Yeah, I think you can see now where the light is falling, it is started to rotating. Yeah, well, and we have used for this project, we have used a mobile app called Blink. And yeah, hope you can see here we have used the 4 button. As soon as the project we will switch on, it will give us the solar axis dual axis solar tracking panel. This is the project name, and this is the voltage, how much it started to observe. And yeah, one more thing, even these 4 buttons, why we have used, you can see here the 4 buttons we have used here. This is the reason where we can control our solar panel manually. Right now you can see I am just clicking on this button, it is start rotating. Even the sunlight is not falling on that. Any light I am not giving, but still it is falling. I hope you can see so. This is why we have used this manually, means sometimes it may get stuck somewhere. Okay, for example, like it went completely like this, and sunlight is somewhere here. When it is not able to track, the LDR sensor is not able to observe the sunlight. So that time we can see that voltage is not showing. So we will get to know that something is wrong. Right now, in that time, we can control our panel using this solar, and we can make sure that it will start tracking the light. It will start observing the light, and it will give us the voltage. So as soon as it will start giving the voltage, we can make sure that it is working complete properly. Thank you, sir.
Hello everyone, myself Sharan PM and my teammate Shivani Harish have developed an IoT project which is Med Reminder. Med Reminder is about reminding the patients to take the medicines at a particular set time. This is the project model we have developed. This is the LCD which is used to display the time and the message. This is the current time. This is the power supply. This is the Arduino Uno board which is used to dump the code and run the model. This is a Wi-Fi sensor which is used for the internet. This is a buzzer which is used for alerting the patients. Using Arduino cable, we dump the code to the Arduino board. This is the code. We have used embedded C as a programming language. In the code, we change the time and it is set to particular time for reminding the patients to take the medicine in the morning and also in the night. Here we change the time and set time. Current time is 22:05, that is 10:05. Change it here. Time is set. We'll upload it to the Arduino board. It's done uploading. Using Blink application, we send the message, and in the Blink application the current time is displayed. We have used two DC motors to open the box. And in the Blink application, morning medicine is dispatched and the evening medicine dispatched. The message will be sent. Thank you.
Hello everyone, I'm Ashwini from 5th Sem MCA department, and my project is Smart Cradle System. This project is aimed at developing an interactive smart cradle system, and this project will help parents while they are working or doing some work. Sometimes they don't have a time to taking care of their baby. That time this project will help them. In this project I'm using Arduino board and Node MCU model and sound sensor. It will detect the baby's crying sound, and this is moisture sensor. This will detect the baby's wet condition, and this is servo meter. This will rotate the cradle. This is the cradle what I'm using in this project. And this is the power supply, and this is breadboard. And this is the code. This is Arduino code, and one more. And This is the notification code. In this project I'm using Blink app to get a notification, and this is the code for that. And now I will give the demo how my project will work. See, baby starts crying and cradle swinging now. When baby starts crying, this servo meter will start swinging. Now cradle is swinging. After 15 to 20 seconds, I'll get a notification from the Blink app. Baby is now I'm getting a notification like baby is crying. And one more feature I have done, this moisture sensor will detect the baby's bed wet condition and it will intimate to their parents via Blink app. And I'll show how it will work. Now I'm putting the water on it. And it will detect the wet condition and now I got a message baby got wet. This is my project.
Hi everyone, this is Trupti and Pooja, and our project is all about waste segregation. Here we are going to segregate the dry and wet waste without human intervention. So we are using Arduino Uno board and IR sensor, servo motor, and moisture sensor. So basically, IR sensor will detect the waste that is placed on this surface. So once the waste is detected, then the moisture sensor will detect the moisture level of that particular waste and will segregate into dry and wet waste. Here. The threshold value that I have kept for moisture sensor is 85. If it is above if the moisture sensor moisture level is above 85, then it is considered as wet waste, else it is considered as dry waste. So I'm going to start off with the wet waste. That is, I'm going to first place the onion on moisture sensor. It is going to then I have a ginger. I'll place it here. So now I'm going to start with the dry waste. I'm going to place the thread here. And the other one is, I have the sellotape. I'll place this here. Waste is getting segregated. Thank you.
Hello, good morning, sir. This is H. Kishan and Manish D of MCA third semester, and this is our IoT project, Pet Care System. In this project, the user can remotely access the dog's daily routine such as video feed, etc. activities, and he can also remotely feed the dog. In this project we are using Raspberry Pi 3B+, relays, spy camera for monitoring, DC motor for dispensing of the food, and DC pump for liquids such as milk and water. And here it falls. And we are using power bank as a power supply. The mechanism in which the food is dispensed is such that this is a wheel structure in which there is a hole. So every time it completes a revolution, it pushes the food pedigree into the hole, and hence due to gravity it falls down to the bowl. This is the starting interface of all the users. Here the user logs in the account. This is the initial interface in which the user faces. There are many options such as live streaming, support, as well as feeding the dog. So we'll go by the first feature, which is feeding. There are two options for feeding, either periodic feeding, which is done through cron tabs, or else remote feeding. So when you click the button, the machine starts to feed. So as you can see, the DC motor turns and the DC pump pumps the water. So together they pour it in the bowl and we can see the outcome. So we are using Firebase as a switch system in which since a click of a button, the motor gets updated to true. The next feature, which is live stream. And the live stream, we can watch it through this. Here we have just created an interface where we are using PyCam and we can monitor the pet. This is done using something called ngrocks. This is a private host service in which you can host your local host onto a server. Hence we can access the video feed from anywhere. So this is how we are accessing local feed to our website.
Hello viewers, myself Surya and Naina are here to show you a real life scenario using IoT project.
Our topic is Smart Crop Protection and Fire Detection from MCA Department 5th semester. Let me introduce our project in detail. Firstly, this project is very helpful for the agriculture in different eras. Somehow, the whole world is depending upon the agriculture itself. In the world, the economy of the many countries is depending upon the agriculture. In spite of the economy development, agriculture is the backbone of the economy. Agriculture is the mainstay of economy. It contributes to the gross domestic product. Agriculture meets the food requirement of the people and produces several raw materials for the industries. But because of the animal interference and the fire in the agricultural land, there will be a huge loss of the crops. The crop will be totally getting destroyed and there will be a large amount of loss of the farmer. And to avoid this financial loss, it is very important to protect the agricultural field or farms from animals and the fires. To overcome this problem, in our proposed work, we shall design a system to prevent the entry of animals into the farm by using PIR sensor. Our main purpose of the project is to develop introducer alert to the farm and to avoid the loss due to the animal and the fire. This introducer alert protects the crop from the damaging that indirectly increases the yield of the crops, and the development system will not harmful and injurious to the animal as well as the human being. Theme of our project is to design the intelligent security system for the farm protection by using the embedded system based on the Node MCU as was shown in the figure. And the animal attack in the India are common stories as nowadays. Due to unavailability of any detection system, these attacks kill villagers and also destroy their crops. Due to lack of proper safety measures, these villagers are left helpless and to their fate. Therefore, a proper detection system could help to save their lives and also to preservation of crops and also Crops of the villages are destroyed due to frequent interference of animals. The crops and the paddy field cannot be always fenced, so the possibility of the crops being eaten by the cows and the goats are very much present. This could result in the huge wastage of crop production produced by the farmer. To make the best use of a mobile application technology and the objectives of the paper, therefore utilizes as shown in the figures coming up. And this system is used by the Blink app, and we are using the Node MCU as the main purpose of this project. And this system helpful to keep away such wild animals from the farmland as well as provider surveillance functionality. And it has been found that odor of the rotten egg helps to keep the wild pigs and deer from destroying the crops. Hence, the farmer manually spray the rotten egg solution on their fields, and firecrackers are used to ward off the wild elephants that destroy the crops. This project is based on surveillance with the animals ward of the system and employed in the farmlands in order to prevent the crop vandalization by the wild animals. In addition to provide the protection, this system distinguishes between the introducer and the authority person using RFIDs and PIR sensor are deployed in the area to detect any motion and hence to turn on the alert notification message to the owner of the field. And it involves the automation of certain methods used to prevent the wild animals from entering to the farmland and destroying the crops. And electronic firecrackers and the rotten egg spray, which has been found useful to the ward of the wild animals. We use hair features based on cascading classifiers for object detection and to distinguish between the animals. So, section of our project.
Okay, let's start connecting the Node MCU to the power bank. It produces 5 volts of power, which is more than sufficient for the Node MCU to work. Yeah. This means that it is connected to the Wi-Fi and it is an active internet connection. So now I have a small adjustment here. I'll be doing that now. I have the buzzer here. Whenever the system is restarted or booted, if the buzzer is stayed on, it doesn't boot up properly and doesn't work. So what I did was, after every connection, I just use this buzzer. I just install the buzzer after the boot. This could be later solved by some simple reasons. See, now it is working. This means that there is a motion detected here. Let me show you a demo. There is an animal passing by. There's some person coming in and he's about to light the crops. Let's see how the flames work. So both the motion sensor as well as the flame sensor were active. The buzzer is set to buzz for a few seconds so that the person who is trying to trespass in our field will get notified and will leave the land as it buzzes. The user does get notified when the fire is there so that he can stop when it is on small scale. If it leads to large scale, it means that not only this crop, the neighboring crops, as well as it could grow up to a large scale.
Hello everyone. So this is our project, which is a face recognition system. This is the UI of it, which we made it a couple of days back. And coming to our setup now. So this is our setup. Here is the camera, which is written show your face, and this is the red light and the green light. Remove that. Yes, this red light will show us that the door is locked, and then when it becomes green, sound will come with a buzzer. So now we're demonstrating the actual implementation of it.
So the ESP32CAM server is now started, and now we move to the UI part of the server, and now we have to turn on face recognition. And first we have to click on start stream, then you have to click on face recognition detection. So the user will come near the webcam, and then first we have to enroll his face. So it's taking the samples. Door is now unlocked. So when an intruder comes near the camera, it will show an intruder alert, and if an admin or already enrolled face will come near the camera, it will detect the face.
And so now the door is unlocked. Okay, so now coming to the components part. So this is the ESP32CAM, which is a microcontroller with built-in Wi-Fi and camera module. So next will come the Arduino Uno. So this actually we are using it for to feed the code into the ESP32CAM. And apart from this, we are just using normal LEDs and a buzzer.
Our project is a women's smart footwear. Nowadays, we heard so many news regarding crime against women. Sometimes they have night shifts or somewhere they will go lonely. So, security is more important for women. We can also see so many devices are there for women security purpose, like smart belt, smart pendant, or Saki app. So, but Vodafone Saki app is mainly for Vodafone prepaid users, and it is difficult to when woman is in danger. It is difficult to use these devices. So that's why we plan to make a device using footwear. So footwear is easily carryable and easy to use. So we can easily use them, and the device should be easy to use and easy to carry with low cost. We added some more features to this device than present devices what we can see. This is a smart footwear. Uh, what we have developed, there is a button which is attached to the devices. This is the button. When woman is in danger, she can press this button. After pressing this button through Bluetooth, we can fetch numbers in women security app. So first women have to register for women security app that we have developed, and after by giving her name and address is optional, and by giving these three numbers, what we for whom she want to send messages. So through Bluetooth, when press this button through Bluetooth, the alert message will send to the number and with location, and with call. This is a big alarm. It will generate a large sound. So here we used Arduino board, Arduino Uno microcontroller, relay board to convert low power to high power. This is big alarm, and this is 9-volt battery. This is basic power supply board, and this is the HC05 Bluetooth. We connected Arduino board to Bluetooth, RX and TX pins, and analog pins are connected for power supply plus 5 volt minus 5 volt. And this is a small alarm. The two alarms are there, small alarm and big alarm. And we connected relay board to power supply and battery and this alarm. Wait. This is the woman security app. First, if we are a new user, we have to register for this by giving username, email ID, mobile, password, and confirm password. If we want to log in, we can create a password. I already registered for this, so I will log in. After login to this app, it will show Bluetooth name, and nearby Bluetooth name also will be showed. So I will first we have to connect Bluetooth. After this, it will ask for register numbers, and there is a panic button. If she lost this slipper, she can press this panic button, and the alert message with location and with call will send to the predefined numbers. I will enter one number for whom I want to send message. Number 98941 671. We can add three numbers here. If I press this button, this is another number. It's generating call. Here I will give Bluetooth connection to the number. I will enter number 7411. We can enter three numbers for whom we want to send alert message. If I press this button, the call will send to the number. So it's generating call, and we can also see the message that Tejo is in danger at location. If we click on this location, it will take them into the Google map. Here I can see my location. I can see my location. The objectives of this project is to develop a system which is easy to use and easy to carry with low IoT, with low cost using IoT. Thank you. Is more important for women, and I think this device will helpful for women. In future enhancement, we can reduce this wires using VLSI. We can reduce this whole device into a 1 rupee coin, and the slipper should be waterproof. In future enhancement, we can enhance this feature. And thank you.
Hi friends, myself Murgesh and then my teammate is Prashant. Our project is agricultural solution using IoT. This is our project kit, and then this is the Arduino board we are using, and then 5-volt power supply, bridge rectifier, filter capacitor, and then GSM module, and then we are using SIM slot here. And then this is the 16x2 LCD display, and then these are the connections to the sensors. This one is a relay connection, this one is alarm, and then soil, humidity, temperature, and then GSM connection. And then this is the temperature sensor, soil moisture sensor, humidity sensor, alarm, and then relay to motor on off the pump. This is the pump we are using for demo purpose. We can switch on the kit, so it will display the messages in 16x2 LCD display. We kept in a dry condition. And then it's getting the data, so 5 accurate counts it will sense, and then it will switch on the motor, and then every alert will be sent to the SMS and then email also. In last I will show that all the messages and all. And then we developed one application also for this to manual work. And then these are the temperature, and then humidity, and then moisture. After the 5 accurate counts, it will display the SMS and then email alert. It's in a dry condition. Send OK. So sending the SMS, and then field at dry condition, motor on. So we can see here motor will be on. So now I will kept in a wet condition. So it's sensing the data. We can see here we are getting a message also field at dry motor on. I am using my brother number, so I am getting a message from that sim. So data okay, field at wet condition, so motor will be off. You can see pump will be off condition. So we are using one Android application. I will show. This is our Android application, smart agriculture using IoT. So this is the application here, showing the motor off, on and all, temperature, humidity, and then soil moisture. So it will sensing each time. So 10 seconds time it will take to sense, so only it will show like that. It will show. One second, guys. One second, I think it's on. Yes, we can see the old data, when will be motor on, motor off. That time it will get the data to this app. All the data will be stored in this app, temperature, humidity, moisture, and then the date and time also. So we can go to main screen. So here I am switch on the motor. So it's in wet condition only. I am switch on the motor in manually. Action completed. Get the data okay. Motor will be on. You can see, guys, motor will be on. Through manually also we can access this project, and then when we switch off the motor, action, send okay. Get the data okay. so it will be switch off the motor. We can manually access the this project also. So this is our project, and then I will show mail alerts also. Mail. So we can see all the mail alerts we will get to our mail. For example, we can take see no moisture detected, field motor, pump horn. So like that, each and every alert message we will get to our mail and SMS also. So this is our project to help the farmers to reduce the time consuming and all. So thank you guys.